At this time, I'm going to take temperature readings. And it does two things at one time. It verifies the electrical property of the dryer, and it also verifies ventilation of the house. And it's just a simple meat thermometer. Oh, very efficient is what I call it. I love this tool. All right, let's ground you out. All right, let's turn that off. Turn the timer off. You want to set this dryer at a setting of 145 degrees, which is permanent, well, which is really delicate permanent press. Traditional heat is 165 degrees, plus or minus 10. And so these dryers don't have to get as hot. So permanent press is the hottest it will get, which was a range of 145 to 155. And that's what I'm going to be checking. This is a heat complaint, and the dryer is generating heat. I already feel. Alright, by doing this, I already feel lint build up in the exhaust housing. And so that's an indicator that it's not the electronic components, but rather the ventilation. And so I can feel it right there. There is lint being forced out. So I'm just going to take this off right now. Good look. Right to the point. Yeah, look at that. That lint right there. So that was about 30% of air flow being prevented. You can see the diameter changes. See that dark area? That's your diameter. And when that diameter changes, restricts the air, and that's how your clothes dry, is from getting hot and getting cold. And I can also feel backdraft. You can actually see how this lint, you can see the air backdraft. So that's heat is fighting against slight backdraft, which the louvers is what protects the air from coming in from the outside back into the dryer. So we'll just remove this lint and the remaining part of the lint that's in the dryer itself, and that should take care of it. Pretty simple. It just needs a good vacuuming.
Do you want me to bring my vacuum?
And that's also a part of the service. That gets taken care of by the trained professional, because we're knowing what we need to look for. And so I do appreciate your offer, but in order to do this 110% correct with no complaints, I'm required. I do appreciate it. And also that reduces liabilities too. So customers are not supposed to do anything but enjoy your excellent work. All right, so let's get this done. We'll just vacuum the rest of this out. And the majority of it's just right in this area. majority of it's been removed. The rest of it would be associated with the humps. Then we're not responsible. I would recommend replacing this exhaust line, but this is satisfactory for now. Alright, so now what I want to do, now I got the lint removed, I want to verify temperature readings. Alright, so we have a setting alarm at 155, and we have the room temperature is 49. Set normal, power on. Alright, so the temperature I'm looking for is 100, not to exceed 165. Traditional, you'll be at 2 minutes 30 seconds with a temperature reading of 165 degrees. That's traditional. When front loaders came out, then the temperature readings was dropped by about 15 degrees. And so now those readings on high are now 155, 145 on these designs. That's normal for these settings on this front loader dryer. On your standard older design dryers, 165 would be the numbers you would be wanting to look for. And so we are getting heat. It's slowly rising, 82. I'm not so much concerned about time and duration and heat. At this time, I'm not concerned about the time. I just want to make sure that it is getting hot. And it is getting hot. That verifies the electronics and the electrical system. The element's getting 240 volts from L1, which would be the house side, and from L2, which would be from the control board side. And so the motor is good. L1 goes through the motor through a centrifugal switch into the element, and then I believe L2 goes through the touchpad control door switch and through the directly to the element. Then it goes from the timer to the operating thermostats to the element through the high limit thermostat. Those are all the safety precautions. So if this dryer ever caught on fire, or we're at 125 degrees. Now 126 used to be optimum for low temperature, but it's not considered optimum at low temperature no longer. Optimal at low temperature for this design, I'm looking for 115. So we're at 138, 139. We're approaching high temperature, 2.5 minutes. Normally you would have 165 at this point. So 145 is where it would be at. It would cycle downward now once it hits its optimum temperature. Should not be no more than 145 plus or minus 10 degrees. Anything above that would be caution. So that's what I'm looking for right now. So if it hits the 165 and it has hit what I think would be where it should start receding in temperature, and it's still steadily going upward. So we're at 160, approaching caution. 164, 165, 166, 167, 145, 155 would be considered standard. So this is right now an operation of comparisons of older design dryers and the newer dryers, which has the thermistor instead of the thermostat. Now it has reached 168 and now it's starting to decline. So the thermistor has registered that it has reached its impedance. Now it's going downward. Now we're going to see how low it goes to reach its optimum cool down, and that was in 4 minutes. Now what they did is they designed these newer dryers not to get as cool. They will maintain their temperature. So 155 is where it would be considered maintaining a temperature.
And what will happen is that the dryer will stay close to that temperature instead of going all the way down to 126 like they used to, which would be optimum, which would be delicate. And so they designed it to where it's called even temp circuitry. It would be a 15 degrees drop, and it will remain a 15-degree drop, and it will not go lower than that. So that's what I'm checking to see now. Now this is about a 10 to 15-year-old dryer, so it has had a lot of usage. So its resistance impedance is different. So now it's climbing back up. So this would be an even temp. This would be an even temp design temperature. This is the very first design, original designs that came out with the even temp, which keeps your clothes heat evenly on the high side versus dropping it down to permanent press, which would be 126. It'll keep it up above the high side, which would be 145 to 155, and it will cycle after it hits that first temperatures range. Now it will cycle evenly within that 15 degrees, and that's what it appears that it's doing. So it's getting ready to drop. It's going to begin its second cycle. Now I'm seeing that the element's going to receive heat from the control board. At this point in time, the thermistor has registered temperature, and which now has removed power from the element. So the element radiant temperature that's coming, the heat that's coming off of the element, radiant heat coming off the element, is now dissipating and cooling down, and that's why it's dropping so steadily. That would be the reason for that. Now what I'm looking for now, if it's going to continue to drop, then that tells me there's an electronic issue. And that's what I'm verifying right now, just by temperature reading. You can see all these things. And so now we drop down to almost traditional permanent, traditional 126 degrees plus or minus 10 degrees from the older design. And so I'm doing comparisons, but as long as it's within these temperature range, then these dryers will perform. And as long as there is no air flow obstruction, then the clothes will get hot and they will cool down and it will vent, and then your clothes will dry within a reasonable amount of time. So now it's going back up. Older dryer, the panel's not hot. And so all that matters is that it is heating and it is cooling, and it is within temperature specs of a dryer, not exceedingly, and not fire damage, or not fire damage, fire hazard for your panels getting hot. Some designs your panels get hot. This would not be that design, but up here, some of your top load traditional dryers, your panels will get hot on top. But all in all, it's staying within dryer specs and temperature. And these are the specs: 126 on the low side to 165 on the high side. And that can be plus or minus 10 degrees usually. 5 would be a little bit too strict. So now we'll just cycle 15 degrees of this high side. Now it's at 140. It was at 147. It just went down to 146. So now it's within that even temp range, and it's going to stay within this even temp range. It should have got above 155 degrees.
So what settings do you have it on?
It should be normal high. Yes, normal and sensory. Now when you have these settings, they are predetermined. Yeah, so this one here is normal, medium, and so normal high, and medium is right there with high. So that is a very good question, because that is not at its maximum setting, but it is within specs. So if you know your specs, regardless of your settings, then if it's a drastic change, then you know that you need to change a sensor. But the specs are 126 on the high side,
165 on the 126 on the low side, 120, 165 on the high side. If you know those specs and temperature and you know what to look for, then you can tell if your dryer is operating efficiently. And so now it's just staying right in that cushion. And this is the second cycle, so now it seems to be cooling down because your front load washer spins at such a high RPMs. Your dryer does not have to get as hot, and it should not have to dry your clothes as long. And that is what the benefits of the front load set was marketed at the time. And so your clothes come out practically damp dry, and that's what everyone was so excited about 15 years ago. And so that's why these temperatures have now have catered to a less heat on your clothes, which would damage the fibers of your clothes. And they'll get less and less heat as they get more and more efficient and more advanced. And we're just at the turning time of the old design electronics, which would be the DUV control boards, the change out to the electronic EUV control, which is basically sensoring and touchpad control, finger touch. No longer lights and buttons. All resistance in the slide of your finger. All tests good. Very satisfied. And it will automatically shut itself off when it does not feel any clothes touching the electrodes that are inside of your dryer. And so if you don't have enough clothes in there, it will turn itself off, because as the clothes are tumbling, there are these are the two electrodes of wires in there that they're touching, which completes the circuit. They do not touch that. And if it does not touch those, then it will speed the time up and it will shut it off like this. Are the two electrodes the clothes have to touch. If they do not touch that or touch those, it will speed the estimated time up and turn the dryer off prematurely. So sometimes this gets wax buildup on it because of the fabric softener sheets and whatnot. And so this is how those dryers will turn off prematurely if you don't have enough clothes in the dryer.